Here in example 2, we have x plus 2y equals -1 and negative x plus y equals 3. Now, the equations are set up in a way that I don't need to do anything other than add these two equations together because x plus negative x gives me 0. So that gives me 0, and then we have 2y plus y gives me 3y, and -1 plus 3 gives me 2. So we get 3y equals 2. If I divide both sides by 3, then we get y equals 2/3. And now I am going to plug that into my second equation. So I get negative x plus 2/3 is equal to 3. Then I'm going to subtract 2/3 on both sides. And this is starting to look familiar. We might have already done this one before up by graphing in a previous example, but let's continue and do this anyway. So 3 is the same thing as 9/3. And we get negative x is equal to 7/3. And if I divide or multiply both sides by -1, then I get x equals -7/3. So I think if I remember correctly, this is a repeat, but up above we did it by graphing. So here is our final answer for that one. Example 3 wants us to solve the system 2y plus x equals 8 and 2y plus x equals 2 by using the elimination method. And luckily, I don't need to do any multiplication. I can just subtract these two equations. So 2y minus 2y is 0, x minus x is also 0, and then 8 minus 2 is 6, and we get 0 equals 6. Because that is not a true statement, we say that this system has no solution. Or another way of saying that is a solution does not exist. And sometimes you'll see that abbreviated as D and E. So that concludes this example 3 here.